Hi guys, we have the case study on the Pensacola Surgery Center. For question 1, it reads, consider the $50,000 excess cash. Assume that Gary invests the funds in a 1-year CD. Part A reads, what is the CD's value of maturity, future value, if it pays 10% annual interest? In Excel, you would plug in the information in the FV or future value formula. For this one, you first put rate and then the number of periods. Make sure that you put 2 commas to get to the present value. And we've added here a negative present value so that our future value will come out positive. For part A, we got 55,000. Part B, it reads, what will its future value be if the CD pays 5% interest? For this one, we again plugged in Excel and did the future value formula. We got 52,500. Then part B also asks, if it pays 15,000 interest, what will your future value be? And we got 57,500. For question 2, it asks us to rework parts A through B of question 1, assuming that each CD has a 5-year maturity. Part A, it reads, what is the CD's value at maturity or future value if it pays 10% annual interest? In Excel, we would use the future value again and plug in the present value rate, again using a negative present value. For this, we received $80,525.50. For part B, reworking the 5% interest, we got for future value $63,814.08. And then if it pays 15% interest for the future value, we got $100,567.86. For question 3, it asks, now consider the surgery center's goal of having $200,000 available in 5 years to buy a new patient billing system. For part A, the question asks, what lump sum amount must be invested today in a CD paying 10% annual interest to accumulate the needed 200%? For this problem, we use the present value function in Excel. For part A, we got $124,184.26. For part B, it reads, what annual interest rate is needed to produce $200,000 after 5 years if only $100,000 is invested? For this, we use the rate function in Excel. 14%, 14.87%.
All right, so for question number 4, it says, now consider a second alternative for accumulating funds to buy the new billing system. In lieu of a lump sum investment, assume that 5 annual payments of $32,000 are made at the end of each year. So part A says, what type of annuity is this? So according to the book, we decided that it's an ordinary annuity because this is an annuity that has payment that occurs at the end of each period. So question 4, part B, asked, what is the present value of this annuity if the opportunity cost is 10% annually? So for this part, we had to find the present value in Excel. And so we plugged in the rate, the number of periods, and the negative payment amount, which gave us a positive present value, which came out to $121,305.18. And then the second part of part B asked, what is the present value of this annuity if the opportunity cost is 10% compounded semi-annually? And so in order to do this, you have to use the EAR for the rate instead of the given rate. And the definition in the book of EAR is the interest rate that under annual compounding produces the same future value as was produced by more frequent compounding. So if you guys want to know a little bit more about that, it starts on page 316 of the book talking about that, and that definition is on page 318. So you'll use the EAR, or the effective annual rate, in place of the given rate to find the present value in this part, and the present value of the annuity is going to be $120,534.40. So question 4, part C, it says, what is the future value of this annuity if the payments are invested in an account that pays 10% annually? So for this part, we're not finding the present value, we are going to find the future value. And so we're gonna, do the same thing. We're gonna plug these numbers into Excel. And so to find the future value of the annuity, the answer is $195,363.20. And then the second part of part C asks what the future value is if it's pays 10% compounded semi-annually. And so for this one, same as the part B, you're going to use the EAR to find that instead of the given rate in the problem because it's compounded more than one time in a year. And so the answer to the second part of part C is going to be $196,337.83. So part D of question 4 asks, what annual interest rate is required to accumulate the $200,000 needed to make the purchase, assuming a $32,000 annual payment? And so once again, we're just going to lay out these numbers and plug them into Excel. And this time we're going to use the rate function in Excel. So we're going to plug in the number of periods, the payment, and the future value. It will give us a rate of 11.18%. And then the last part of question 4, part E, asks what size annual payments is needed to accumulate $200,000 under annual compounding at a 10% interest rate. And so because it says annual compounding, we know that we can just use the given interest rate in this problem. And so we'll plug this information into Excel under the payment function and make sure that you have the 2 commas in there between the number of periods and the future value so that you have the correct, you're plugging in the correct numbers in the correct spaces, and your payment amount is going to be $32,759.50.
Question 6 says, now consider the uneven cash flow stream stemming from the lease agreement given in the case. And so for this one, we're going to use the net present value function in Excel, just like we have for a lot of the other ones. So in part A, it says, what is the present or year 0 value of the annual lease cash flows if the opportunity cost rate is 10% annually? So if we plug in the information given into the NPV function in Excel, we get $47,328.61. And then for part C of question 6, it says, does the office renovation and subsequent lease agreement appear to be a good investment for the company? So if we figure out the NPV for this part, we come out to a positive $7,328.61. So we would say that yes, since the renovation returns a positive net present value, it would be a good investment. And question 7 reads, now assume that it is 5 years later and the company is unable to accumulate the $200,000 needed to purchase the software. Instead, it is forced to borrow the $200,000. The loan calls for repayment in equal annual installments over a 5-year period, with the first payment due at the end of 1 year. Assuming that the company can borrow the funds at a 10% rate, what amount of interest and principal will be repaid at the end of each year of the loan? So for this one, in Excel, we plugged it into an amortization table for the loan. So we use the loan amount of $200,000 and the interest rate of 10% annually, with 5 years being the periods. So when we plug that in, we get payments of $52,759.50 for each of the 5 years. And then you can see that it puts the interest in the principal, and it eventually zeroes out at the end of 5 years. And if you want to do it the longhand way for calculating amortization, this is the equation you use, and you just plug it in. And as long as you keep your rounding until the very end, you should come out with also 0 cents at the end, but sometimes rounding doesn't come out all the way complete, so we ended up with 0.01 at the end.